in order to add or subtract with radicals, we need the same number under the radical. So here we can't subtract right off the bat, but let's simplify them to see if we can get them to be like terms, if we can get them to be the same number under the radical. So we got to simplify one at a time. What are 2 factors of 125? 25 and 5, perfect. And 2 factors of 25? 5 and 5. So we circle whatever pairs we have because here it's implied that it's a 2 when there's no index written. So I've got 2 5s. So what's going to come to the outside? A 5. What stays on the inside? A 5. The 5 that did not get circled stays on the inside. Let's do the same thing with the second one. What are 2 factors of 45? 9 and 5. And 2 factors of 9? 3 and 3. So we circle our pair of 3s. What comes to the outside? 3. I already have a negative there, so it'll be negative 3. What stays on the inside? 5. So here, can we combine them together now? Yeah, so we just add or subtract the whole numbers out front. Here we're subtracting them. So it's 5 minus 3. Awesome. So it'll be 2 square root 5. And the square root part just stays the same. All right, I'm going to do one more simplifying one just for practice. Let's say I had 4 square root 8. So just for practice, let's say we had 4 square root 8. What are 2 factors of 8? 4 and 2. And 2 factors of 4? 2 and 2. So what would I circle? 2 2s. So what comes to the outside? A 2. But I already have a 4 on the outside. So what do I do with the 4 that's already there? I multiply it to the 2 that I'm taking to the outside. What stays on the inside? 2. So this would be 8 square root 2. So if you have more than one thing that you take to the outside, multiply it together. If you have more than one thing that stays on the inside, multiply it together. So any questions with number 1? Good here. Let's do number 4. So number 4, we want to distribute the exponent. Now, there's a couple different ways of working this out, a couple different orders that you could do it. If you wanted to make your exponents positive first, you could do that. I'm going to distribute, and then I'll make them positive at the end. So when we distribute our exponent, we have 8 to the second power, and then x to the 6th power to the second power, and b to the negative 3 power to the second power. So the exponent of the 2 gets distributed. It's now an exponent on everything on the inside. What is 8 to the power of 2? 64. What do I do when I have a power raised to a power? Multiply. So this would be x to what power? To the 12th power. And then again, we have a power raised to a power, so we multiply. So we have b to what power? B to the negative 6th power. Now we can't leave negative exponents in our answer, so what would I do to make that a positive exponent? We move it to the bottom. So I'm going to turn this into a fraction. Any negative exponent gets moved to the bottom, and the exponent turns positive. So this would be 64x to the 12th power over b to the 6th power. Perfect. And when we move it to the bottom, it turns to a positive exponent. So the exponent changes signs when you move it. All right, let's do number 5. 5 is similar, but we may want to simplify inside the parentheses first before we distribute our exponent. It'll make the numbers a little bit smaller, so just simplify what you can. So remember, we can only combine them if they have the same base, so I can combine the x's together, I can combine the y's together, and then I can combine the z's together. When we're dividing, what do we do to the exponents? Subtract the exponents. Can I combine the numbers? Can I simplify negative 3 over 2? No, so I'm just going to leave it as negative 3 on top and 2 on the bottom. Then when we subtract the exponents, we subtract the top minus bottom. So it's top minus the bottom. So 7 minus 8 would be what? Negative 1. We're going to leave that up top. So x to the power of negative 1. We'll make it positive later, but we'll leave it up top for now.
We're supposed to subtract the top and the bottom before we make the exponents positive?
I would, but there's different ways that you can do it. You could make them positive, so you could move it and then combine it together. I'm just going to combine them. You'll get the same answer if you do it correctly. So again, let's combine the y's. We do top minus bottom. So negative 2 minus 9 would be what? Negative 11. They're both negative. They have the same sign, so you add them. So y to the power of negative 11. And then let's do the same thing with the z's. Top minus bottom. So 5 minus negative 4. What would 5 minus negative 4 be? 9. Awesome. This turns to a plus when you minus a negative. So 5 plus 4 would be 9. So you have z to the 9th power. And this is all still to the 4th power. So there's different ways that you can do it from here. So notice how when we subtracted our exponents, everything just stayed up top. But some of them are negative. So you could make it positive in this step. Or if you want to distribute and then make it positive, you could do that too. So there's different ways that you can do this. You can make them positive first, then distribute, or distribute, then make it positive. Doesn't matter the order that you do it. What would you rather do? Make it positive or distribute first? Let's make it positive first. So anything that's negative on the top, we need to move it to the bottom. What if it was negative on the bottom? You move it to the top to make it positive. Perfect. So we have negative 3 and z to the 9th power left up top. And then on the bottom, we have 2. What happens to the exponent on the x? It would turn positive. So what would I write? Would I write x to the power of 1?
No,
just x. You don't put the exponent when it's a 1. And then we have y to the 11th power. Now what can we do? Let's distribute the exponent of the 4 so it gets distributed to everything. So we have negative 3 to the 4th power. We have z to the 9th power to the 4th power. 2 to the 4th power. X to the 4th power. And y to the 11th power to the 4th power. We distributed, so we don't really need the parentheses around the whole thing. But let's work it out. What's negative 3 to the 4th power? Awesome. Remember, it's negative 3 times negative 3 times negative 3 times negative 3. Write it out if you need to. If you can't do it in your head, write it out. Negative 3 times negative 3 would be 9. Negative 3 times negative 3 is 9. And 9 times 9? 81. So we get 81 up top. What do we do when we have a power raised to power? Multiply. So z to what power? Z to the 36th power. Perfect. Then what's 2 to the 4th power? 16. Awesome. Write it out if you need to. 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4 would be 16. So we get 16. Next we have x to the 1st power to the 4th power. So that would be x to the 4th power. And then again with y, what do we do when we have a power raised to power? Multiply. So y to the 44th power. So that would be as simplified as we can go. We combined all of our same bases. Can I divide anything into 81 and 16? No. But always just double check. See, do you have a common factor? So I have 2x over y to the power of negative 3. What should we do first? Sure, we could distribute. So let's distribute everything to the power of negative 3. So 2 to the power of negative 3, x to the power of negative 3 over y to the power of negative 3. What can we do next?
Simplify.
Let's simplify. How do we make our exponents positive? We got to move them to the bottom. So anything on top that's negative, we're going to move it to the bottom. What if it's already on the bottom and it's negative? Move it to the top. So now we have y to the third power up top. And then we have 2 to the third power and x to the third power on the bottom. And then what's the last step? Simplify. What's 2 to the third power? So remember, 2 times 2 times 2. 2 times 2 would be 4. Awesome. 4 times 2 is 8. So that would be our answer. Don't forget to make your exponents positive. So with 7, we're multiplying our radicals. So when we multiply them, we can combine them together. We can make it the square root of 10 times 30. You can multiply these together, or if you want to skip a step, just start breaking down each one from here. If you multiplied them together, you would get 300, and then you would say, what are 2 factors of 300? 10 and 30. So we just kind of skipped a step there. So what are 2 factors of 10? 5 and 2. What are 2 factors of 30? 5 and 6, that works. And what are 2 factors of 6? 3 and 2. Awesome. Do we have any pairs? We've got a pair of 5s. Anything else? A pair of 2s. So what comes to the outside? 5 and 2, but what do I do with them? Multiply. So 5 times 2 comes to the outside. What stays on the inside?
3.
3 did not get circled, so it has to stay. Awesome. So our answer would be 10 square root 3. So let's practice a square root one or a radical one. What's my index here? 4. So that tells us we need 4 of a kind. So let's start with the number. Let's break down 32. What are 2 factors of 32? 8 and 4. What are 2 factors of 8? 4 and 2. And 2 factors of 4?
2 and 2.
2 and 2. And then we have 2 factors of 4 or 2 and 2. So we said we circle how many of a kind here?
4.
4. So I've got 4 2s. So what comes to the outside?
2.
A 2, because we've just got one circle, so just 1 2 comes to the outside. And then we have the 4th root of what stays on the inside?
2.
2. So whatever the index is in the question, you got to make sure you put that index in your answer too. So that's why the 4 stays on the square root. Let's do the same thing with the x's. How many x's do we have here? 10. You can write them out if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of a kind do we circle? 4. So I've got 4 of a kind, 4 of a kind, and 2 left over. What comes to the outside?
2.
Just 2?
2x.
How would we write that? Not 2x, but x to the power of 2. What stays on the inside?
X.
How many x's did we not circle? 2 did not get circled, so 2 stay on the inside. So x to the power of 2 stays on the inside also. So since we had 2 circles, 2 x's come to the outside. So that would be x squared. And then 2 x's did not get circled, so 2 x's stay on the outside. So x squared on the outside as well. Let's do number 9 next. So here we're subtracting. We need to combine our like terms and put it into standard form when we subtract. But what's the first step that we have to do when subtracting? Distribute the negative. Perfect. So we've got negative x squared minus 7x minus 2. So starting with our highest degree, we have 5x to the third power. Nothing gets combined with that. We don't have any like terms. Then we have 4x squared minus x squared. What would that be? 3x squared. Then negative 3x minus 7x. Negative 10x, awesome. And then lastly, just the constant, negative 2. So this would be our answer, and this is in standard form. What should we do for number 10? Distribute. So what's negative 7x squared times x? Negative 7x to the third power. Awesome. What's negative 7x squared times 3? Negative 21x to the second power. Yeah. Is this in standard form? Yes. So this would be our answer. All right. I'm going to do one more bonus one of multiplying here. What would I do when I have 7x minus 4 squared? We do not distribute the exponent here because it has a minus. We FOIL. Let's write it twice and FOIL it out. If you want to use your shortcut formula, you could do that. But let's write it twice and FOIL it out in case we forget our formula. I think writing it twice and FOILing it out is the easiest way to do this. Let's see. So let's FOIL. What's 7x times 7x? 49x to the power of 2. Perfect. 7x times negative 4? Negative 28x. Negative 4 times 7x? Negative 28x. And negative 4 times negative 4? Plus 16. So we have 49x squared. When we combine our like terms, what's negative 28x minus 28x?
56.
Negative 56x plus 16. Perfect. So that's our answer. Is it in standard form?
Yeah.
Yes. Let's look at number 3. So that's 6. This number 3. There we go. No, I was looking at 6. All right, so let's simplify. Remember, we're adding, so in order to add, they have to have the same square root, and they have to be like terms. So we have the cubed root of x to the 4th power. How many x's do I have under here? 4. How many of a kind do I need to circle here? 3. So we've got 3 x's. How many come to the outside? Just 1 x, because we just have one circle. So x. Then we have the cubed root. How many stay on the inside?
1.
Just 1, because 1 did not get circled. Let's do the same thing with the second one. So what are 2 factors of 8? 4 and 2. 2 factors of 4? 2 and 2. How many of a kind do we circle here? 3, because our index is 3. So what comes to the outside? 2, because I have one circle of 2, so just 1, 2 comes to the outside. What stays on the inside? X stays on the inside because x doesn't have any of a kind. 4 broke down into 2 and 2, so we circled that. So be careful there. So these do have the same cubed root. It has the same radical part. But are they like terms? No. So we can't add them together. So this would be our final answer. I think on the answer key, Miss Glick might have written it like x plus 2 times the cubed root of 3. Either way is fine. As long as you know that you can't add them together, yes. 13, we have 2 terms times 3 terms. So we have to make sure everything in the first set gets multiplied to everything in the second. So starting with 2x to the 3rd power, we're going to multiply that times all 3 things in the second parentheses. So what's 2x to the 3rd power times x squared?
2x is 6.
What do we think? 2x to the 5th power. Remember, when you're multiplying, add the exponents together. So if I have x to the 3rd power times x to the 2nd power, you add the exponents.
But wouldn't the exponent combine to make another one?
No. Because this is like saying we have 3 x's. X times x times x times 2 x's. So how many x's do I have now? 5. So this would be x to the 5th power. So the x's don't combine when you're multiplying. You just add the exponents. So we have 2x to the 5th power. What is 2x to the 3rd power times negative x? Negative 2x to the 4th power. Perfect. And then 2x to the 3rd power times 7. 14x to the 3rd. Awesome. Let's do the same thing with the negative 5. So that gets distributed to everything in the second parentheses. So what's negative 5 times x squared? Negative 5x squared. What's negative 5 times negative x? Plus 5x. And negative 5 times 7? Negative 35. Is this our final answer? Can we leave it like this? Yeah, we don't have any like terms here. Is this in standard form? Yes. So just make sure you combine your like terms and you put it in standard form. If you don't have any like terms and it's already in standard form, then that's your final answer. So for 14, it says to write it in standard form. What would we start with when we put it in standard form? The highest degree, which is negative 6x to the 5th power. What would come next? Negative 19x to the 3rd power. Perfect. Then what? Plus 7x squared. Then plus 3x minus 1. Awesome. So you always want to start with the highest degree and then just decrease from there. What is our highest degree? 5. So the degree of this would be 5. What's our leading coefficient? Negative 6. The leading coefficient is the number in front of your highest degree term.